Okay, hello everyone in a new video. In this one we are going to explain or discuss part 3 of chapter 1, which is the chapter of electrostatics and the first unit of electricity for grade 10 students. So, let me start by solving exercise number 4. Then in this exercise they are telling us that a glass rod G is rubbed using a silky cloth S. So here the rubbing is a keyword that the method of electrification which is being used is friction. Hence, the rod is positively charged. Given the elementary charge, which is constant, which is the smallest entity of charge given by 1.6 times 10 to the power minus 19 coulombs. Now, in number 1, so they are telling us name the method of electrification involved in this process, and this is electrification by friction because it involves rubbing. Now, in number 2, they are asking whether RS and G are classified as conductors or insulators justify. So always in physics try to relate parts to each other. Since in number 1 the method of electrification which is involved is friction, and friction is only used for insulators, then these are insulators. And let me say, since friction is used to charge or electrify insulators, then S and G are insulators. Now in number 3 we're asking specify with the justification the type of charge of S. So since the rod, which is G, is positively charged, and while rubbing they carry opposite charges, then let me say, since G, then S would be positively for sure negatively charged. But let me say that since G is positively charged, then S is negatively charged. Now in number 4 they're asking, or they're telling us that deduce whether G and so whether they admit an excess or deficit of electron, and this depends on the sign. So let me start by discussing G. Now since G is positively charged, and since it's positively charged, then this means it has a deficit, which means a loss of electrons, or in other words, a gain in protons. Now S, which is negatively charged, and this reflects the fact that it has an excess. Now this is important. Why? Because whenever this is a deficit, then the charge can be expressed as an E, and whenever it is an excess is given by Q is equal to minus NE. And now by that, in number 5, so they are telling us that the number of migrated electrons is given by 2 times 10 to the power 11 electrons. So here the electrons have been migrated either from G to S or S to G. Since G is positively charged and S is negatively charged, then the direction of migration is from G to S. Then let me say in 5.1 that we need to calculate QS, which represents the electric charge of S, and S represent the silky cloth. So QS, and because S is negatively charged, then it's given by N minus N multiplied by E, so minus. Now the number of electrons is given by 2 times 10 to the power 11, and the elementary charge is given 1.6 times 10 to the power minus 19. Now plugging this numerical expression on the calculator, then because here we have a minus sign, it would be minus 10 to the power minus 8. Since this is expressed in coulombs, then this will be expressed in coulombs. Remember that all quantities in physics must have unit. Now in 5.2, we are asked also to calculate the charge of a G. Now because G is a deficit, then it's gonna be an NE, which is 2 times 10 to the power 11 multiplied by 1.6 times 10 to the power minus 19. And plugging this numerical expression on the calculator, then it's given by 3.2 times 10 to the power minus 8. All quantities in physics must have unit. Since this is expressed in coulombs, then this is expressed in coulombs, which is in the SI. Finally, in number 5.3, they are asking us to calculate or to compare QG and QS, and this is done, so always the comparison is done by calculating the ratio QG over QS or QS divided by QG. So let me calculate the following ratio. So let me say, for example, QG divided by QS. Now the value of QG is given by 3.2 times 10 to the power minus 8 coulombs, and this is given by minus 3.2 times 10 to the power minus 8 coulombs. So the value is gonna cancel and the units are gonna cancel as well. We're left with minus 1, which means that QS over QG over QS equals to minus 1. And now if you cross multiply, we are left with that QG is equal to minus QS. So this is the relation that holds, or the comparison that holds, between the charge of G and the charge of S. And now by that, let's move to the next important section, which is another electrification method, and this electrification method is known as electrification by contact, which is conduction. Then let me write down section 7.2. So electrification by contact, and this is known as conduction. Now, previously in 7.1 we have discussed the method of electrification, which is by friction, which is used to charge insulators. Now, as we shall see that this one shall be used in order to electrify conductors. Now, so each method of electrification has its own pros and cons, or we can say its advantages or disadvantages. So here, before I start write some statements regarding what's happening here, let me first explain briefly. So now here, what we're gonna do is we're gonna bring a negatively charged ebonite rod. So this is an insulator. Then the electrons will be localized on the tip of this rod. And now what we're gonna do is the following. We're gonna bring the rod in contact at a certain location to the sphere. Now notice that this sphere is a neutral conducting sphere, so initially it doesn't carry any excess or deficit of charges. It has electrons and it has protons, but they cancel each other, and this is neutral. And notice that the sphere is being placed on an insulator stand. The moment this rod is brought in contact with the neutral conducting sphere, the electrons gonna migrate from the rod to the sphere. Now the electrons being found at this location, and this is a conductor, so the electrons can flow easily through this conductor. So there will be a force of repulsion between the electrons, and the electrons will spread across the surface of the conductor like this. Now the thing is that This is an insulator stand, so we need to make sure that the conducting sphere is an insulator stand, otherwise the electrons will escape across any conducting body. Then let me write number 1, that electrification by contact so this is contact, known as conduction, is used to charge conductors and this is due to the fact that since electrification by friction is more challenging for conductors. So this is basically just a small introduction. Now statement number 2, we're gonna say that negatively charged ebonite rod is brought in contact with the neutral conducting sphere. So this is exactly what's happening in document number 1. So if this is document number 1, let's see. Now what's gonna happen is the following. Electrons will migrate from the ebonite rod to the conducting sphere hence the sphere admits an excess of electrons, making it negatively charged. So now let me here mention the following important note is that previously in the method of electrification by friction, I mentioned that if one of the bodies is positively charged, then the other body is directly negatively charged. Now here, this is not exactly the same. So because electrons are being migrated from here, from the rod to the sphere, so this is negatively charged, then this will be negatively charged, because one of them is initially neutral and the other is negatively charged. So recall that in the case of electrification by friction, as one of them is positive, then the other is negative, because initially both of them is neutral. So here, if one of them is negative, then the other will be negative, because the ebonite rod is negatively charged and this is neutral. Now let me mention here statement number 4. So the conducting sphere being found, so the conducting sphere is placed on an insulator stand to trap the electrons. So this is very important here. This clarifies the role of the insulator stand. Otherwise the electrons gonna escape and we won't be able to form this state, which is the static state. And now regarding that, let me mention in idea number 5 that electrons being found on the sphere at the location of injection, or let me say at the location of contact, will experience a repulsion force, since they are all of them negatively charged, and a redistribution of charge will occur. In which all negative charges will spread on its outer surface. Now here exactly what I'm saying is that when the electrons are being ejected on the sphere, since they are all negatively charged, they will repel each other. This is the repulsion force that I've mentioned. And a redistribution of charge will occur. And because this is a conductor, they will gonna move easily on the surface of the sphere. No electrons will be found on the center. All of them will be found on its outer surface, and they will be distributed in this way. Now here in this case we can distinguish between two states. Now this is said to be the transient state, in which electrons are being ejected here and redistribution occurs whenever the electrons. So transient means they are in the case of motion, and the static when they are at rest, no motion occurs, in which they are distributed on the surface of the sphere. Now, so this part from here to here, in which electrons being found on the sphere at the location of contact will experience a repulsion force and the redistribution of charge will occur. So till here, this is said to be or is known as the transient state. And the static state is when all negative charges will spread on its outer surface, and this is known as the static state. And by that, let me solve the following exercise as a direct application on the electrification by conduction. So let me say exercise number 5. A conducting sphere as placed on an insulating stand is brought in contact to a negatively charged ebonite rod E, hence S is electrified. Then the elementary charge is given by that. Number 1, name the method of electrification implemented to charge S. So there is no rubbing, there is just contact between the two bodies, and notice that one of the bodies is a conducting sphere. So this is electrification by contact. Now in number 2, specify the direction of migration of electrons. So in this case, so this is the rod and this is the sphere. If this is negatively charged, then the electrons gonna migrate from the rod to the sphere, and the direction is given from E to S. Then let me say without any justification from E to S, and this is straightforward. Now so deduce whether S is positively or negatively charged. Since S gains some electron from the migration of E to S, then S is gonna be negatively charged. Alright, now number 3, they're asking or they're stating the role of the insulating stand, and we know that the role is to trap the electrons. Now in number 4, they're asking us to describe or to distinguish between the transient and the static states of the electric charges. So we know that the transient is that when the electrons gonna be ejected to the surface of the sphere and they're gonna repel and the redistribution of charge occur. One can describe this transient state in his own language. So let me say exactly that electrons being found on the sphere at the location of contact will experience a repulsion force and a redistribution of charge will occur. Now the static state, static means that they are at rest. Negative charges, which means the electrons, will spread on the outer surface this is it. Now let me make, okay, it's fine. Now in number 5, they are telling us that the number of migrated electrons is that. Specify whether S has an excess or deficit of electrons. So this is important because later on 5.2 we're gonna calculate QS, and QS has two different forms given by minus NE or NE. This is for the excess and this is for the deficit. So let me say that in 5.1 that S, so this is an axis, and this is simply because QS is negative. Now in 5.2 they are asking us to calculate QS. Now since this is an axis, it's gonna be minus n multiplied by E, which is minus, and it's gonna be 4 times 10 to the power 12, and the elementary charge, which is fixed, which is given by that. Now plugging this numerical expression on the calculator, then it's given by minus 6.4 times 10 to the power minus 7 and this is in coulombs, because this is expressed in coulombs. Now let me make some space above. Now in 5.3, they're asking us to determine rho s, the surface charge density of S, given the following formula: Qs equals to rho s 4 pi r square. Independent of our prerequisite knowledge regarding surface charge density, so remember that physics or just solving or calculating a quantity can be divided into two parts: the law or the relation. So we already have the relation, we're done with the first part, and regarding the second part is the mathematical skill, which is the flirt. So we can simply flirt rho s. Now now we're gonna do a flip, so this is a rho s 4 pi r square equals to qs. So this is up, it's gonna be down, then rho s is gonna be qs divided by 4 pi r square. So always before replacing any numerical value, the literal expression is always important. Now the value of qs is given to be that. Now the 4 is 4 and pi is pi. Now what about the value of r? R is 10 centimeters, and you know that centimeters don't as a unit of length. Now c is 10 to the power minus 2, so between brackets we can say that r, which is 10 centimeters, can be written as 10 to the power minus 2 meters, which is 0.1 meters. Now this is equal to 4 times 10 to the power, the value of qs is given by minus 6.4 times 10 to the power minus 7 divided by 4 pi, and this is r, which is 0.1, and we don't forget the bracket. Now plugging this fractional expression as it is on the calculator, then the value of rho s is gonna be minus 5.09 times 10 to the power minus 6. Now since we know nothing about this, so it's enough to say that the unit of rho s is given by System International. Now for example, one can derive the unit of rho s, since this is in coulombs and this is in meter and meter square, so this is gonna be coulombs per meter square. So we can write here, for example, coulombs per meter square. But at this level, this answer would be accepted. I don't expect students at this moment they have any prerequisite knowledge regarding dimensional analysis. So that's it for me in this video, guys. In the next part, we're gonna discuss another electrification methods related to conductors.